So, does anyone know, use Netdata from here? No. Datadog? Datadog. Grafana? Well, of course. The old ones, Nagios, Zabbix, CheckMK, PRTG, SolarWinds, none? Okay, okay, that's great. So guys, I am Costa, I am the founder of Netdata. Netdata, when I started, you know, my goal was not to build a monitoring solution, the opposite actually. So I was really pissed off with monitoring solutions. I was a COO in a fintech company. We had severe problems while migrating to cloud, really severe problems. And after spending a few million in observability, I had the illusion, you know, I had the impression that all the monitoring systems are an illusion. They don't actually monitor anything. So after thinking about it, I said, wait a moment, something is wrong here. Monitoring systems should work in a different way. So the biggest problem of existing monitoring solutions, even today, is the fidelity. So the cardinality, the number of metrics that they have, the number of time series that they have, and the frequency they collect the data is very low. It's very low even for machine learning. You cannot do much. The second is that it's very inefficient in troubleshooting. So in most monitoring solutions, in order to troubleshoot, you have to speculate. So you see a dive in your business metrics, and then you say, oh, let's see if it is the database. Oh, no, it's not the database. Let's see if it is the network. Oh, no, it's not the network. Eh? And you go like this. You speculate. So your experience determines the outcome. There is no AI and machine learning, not widespread. Even in Datadog, the machine learning that they have is very limited, let's say, to just very few things. And in most of the cases, it is an expert system. So there are statistical algorithms that they look smart. But in reality, most of the observability solutions today are pretty dumb. And of course, it is expensive. Even for the Grafana case, for example, the cost of maintaining this ecosystem, the skills required, the effort required is tremendous. So, to my understanding, there is either too little observability, so all the old ones, Nagios, Zabbix, all these kind of tools, too little observability. There is either too complex observability. Grafana is an amazing tool, extremely powerful, but too complex, just too complex. Or too expensive observability, the Datadogs and the likes. So, and this is how I think the monitoring systems, the observability platforms have evolved. So initially we had the check-based systems, Nagios, Zabbix, CheckMK, all this. Then we had metrics and logs. Actually, metrics and logs could be together, let's say. They happen together. Then we have the all-in-ones. And what I believe that Netdata represents is the next generation that is all-in-one, real-time, high-fidelity, AI-powered, and cost-efficient. So there are a few things that I believe are the industry says that these are best practices. But I say that these are bad best practices. They should not be there. The first is this. Monitor only what you need and understand. It's obvious that they do this because the way their monitoring solutions scale, they have to tell you somehow to limit the number of sources and to limit also the frequency you collect data. So they have to do it. And so they tell you, okay, monitor only what you need and understand. But in reality, this is extremely limiting for many reasons. You don't have a holistic view, so your skills depict what you are going to monitor. If you don't understand a metric, you are not going to have it, even when you need it. There will be no machine learning across the board. And of course, as the environment changes, you will have to go through the same process of deciding what you need now, what you don't need, etc. To my understanding, we should monitor everything, no matter what it is. The second bad best practice is monitoring every 10, 15, or 60 seconds. The problem I had when I started with Netdata was that the VMs on the hosting provider were frozen for seconds, but hundreds of servers were frozen hundreds of times per hour randomly. So you can understand, freezes of 1 second, what are they? They don't appear anywhere. They don't appear in logs, they don't have exceptions, you don't have anything. But your whole infrastructure goes in slow motion, goes like this. Does not run. So the biggest problem that they have, all the monitoring solutions, is that they don't work in a bit. So if you have Prometheus and Grafana, for example, in even Datadog, and you go there and one sample, let's assume that it's every 10 seconds, it's not collected every 10, but every 12. It's 10, 10, 10, 12. Are you going to notice? No, you're not going to notice, because the visualization smooths it out. In a data, we collect data per second. If a sample is missing, it's a gap. The chart does not continue. It's a gap. This is extremely important, especially in cloud environments. So with this, we managed to find a ton of problems in hosting providers. The next is that you need to design custom dashboards by hand and beforehand. So you have to sit down and think what could be wrong and what data do I need, and design all the dashboards one by one before actually you need them, just in case. No, is the answer. Why to do that? So the first realization is that all of us use the same components. We have completely different infrastructures, right? Mine is completely different than yours. But the components we use are the same. I use a database, I Postgres, you use a Postgres. I use an Nginx, you use an Nginx. I use an HA proxy, you use an HA proxy. I use a Linux, I use a Linux. I use an Ethernet interface, you use an Ethernet interface. It's the same. And it's a finite set. So the idea is, what if we can provide dashboards for all metrics of everything? So that you don't need to build dashboards. Dashboards are there. So these are the best practices as I see them. Oh, and of course the ML that is completely missing. So even the fidelity. This is, I will go, there is a slide dedicated for this, we will come back. I think we discussed this, about what affects fidelity. To understand this is important. The data, for example, on an empty VM will collect about 3,000 metrics per second. Datadog, on the same VM, extracts 100 metrics every 15 seconds. Netdata has 450 times more data. This is why they don't do it, because it's expensive. So what do we do? How Netdata changes this? The first thing is that we keep the data at the edge. So you have 1,000 servers, you have 1,000 databases. Of course, it's the agent. You don't install a database. You don't install a Prometheus or something there. The agent is in a box. Everything is there. So when you shard that way, suddenly the compute power that you have to actually do queries or do analysis or run ML, etc., 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 the first thing is that it's available and spare. You have it already. And the second is that it's a magnitude bigger compared to any centralization server you can have. So it's faster. These are the concerns about this. We hear this a lot. Okay, if the agent is so fat, then it's going to be heavy. So compared to the Datadog agent, you are going to require more resources at the edge. Actually, the Netdata requires 1/5 of the Datadog agent. It requires about the same in terms of CPU, but significantly less RAM compared to Grafana agent. There is a blog on our site that we compare everything. So we tested them on a lab to see that actually the agent will be heavy is not there. And the data is one of the lightest. queries will influence production systems. No. When you shard per node, then the query that every node runs for itself, it's a tiny thing. The data set is very small, and you are doing a very small query. So it's not even noticeable. The next is that queries will be slower. We said it. No, actually, you have a lot more horsepower. They will require more bandwidth. Yes, queries will require more bandwidth. But the biggest problem with data, with ingress data, especially in monitoring, is the streaming of data, the constant streaming of all data. Here you have only what you view. But what you view is small. What do you do? Every metric, you go on every metric and look at every day? No. So you view just a little bit of what is collected. So the bandwidth is significantly less. If you see the data on an empty VM, you are going to have, just install it. It's an agent, a command, you run it, runs. This is what you are going to get. 150 charts, more than almost 3,000 today, 3,000 unique time series, 50 unique alerts out of the box, system did Journals Explorer, so logs, Grafana like Loki, Elastic, Kibana. A Network Explorer, so you can see every socket in or out of the server. Unsupervised anomaly detection for every metric. 2 years of retention using 3 gigabytes of disk space. And it's going to use just this. 1% CPU of a single core, 120 megabytes of RAM, almost no disk I/O. Sounds like impossible. So this is an agent. This is what happens inside an agent. An agent that discovers the metrics. So, guys, we solve the problem of scalability. So why to have people configure what metrics they want? All of them. Let's collect everything. So we found the Postgres, that one too, and Nginx, okay. We found whatever it is there. Everything, collect everything. Okay? So auto-discovers everything. Of course, in Kubernetes uses etcd, etc., to discover all the sources. It collects automatically all the data. So it goes here. This is a feedback loop, so I'll discuss it later. It goes here, we store, okay? At the storage, we have half a byte per sample on disk, half. This is unique. Prometheus has either 2.3 or 1.3, something like that. Most of them struggle to go close to 1. We are at half. And the reason for that is that in the database, we don't store the timestamp and the value. It's an array. It's a fixed step. All steps, all slots should be filled. So we store the timestamp every 1,000. Not every sample has a timestamp. This allows the data to be extremely optimized. Then we have Gorilla compression, ZSTD on top of it, and we achieve this at the end. So we store the data, and then the same application, that's one application, run health checks and triggers alert transitions at the edge. Has 2 query engines. We're going to discuss about the scoring engine. It can export data to third-party time series, Prometheus, or whatever you want. And actually, we can filter and downsample the metrics in order not to overload the other system. So we can collect every second and do everything every second, but export every 10 seconds or 15 or whatever you want. This is a streaming feature of the data. This point is connected there. So data from one agent can go boom and enter another agent. This is how you build a pipeline like a Lego. And, of course, learning is machine learning. And here we do anomaly detection in real time as samples are collected. So when you're installing the data, what you actually have is, if you have these 5 servers, you have actually 5 dashboards. Each agent has its own. It has a port. You have to hit the IP and the port. Boom, and the dashboard comes up. And every agent dispatches alerts by itself. But then we have developed this, Netdata Cloud. This is a SaaS offering. It has a free tier 2, where without doing anything else, all the agents become one magically. Without pushing, the Netdata Cloud does not centralize the data. Right? It just knows which agents you have, which data they have, stuff like that, metadata. But whatever you see at the dashboards or the alerts there are for your whole infrastructure. You can have centralization points within your infrastructure. So this parent, S6, is a centralization point. So all the data of these servers are replicated there. This allows you even to offload the production systems, remove ML from them or whatever, have high availability. S6 can be clustered, so you could have S6 and S7 there in a cluster, active. And you can use this functionality, the parent, for a DMZ, to put it in a DMZ. So you have an air-gapped environment, you put a parent there, all of the observability ends up in this point. This is connected to the internet. Your production systems are air-gapped. And this is a more complex setup. So the idea with Netdata is that you don't need one centralization point. Actually, you don't need any. But if you want to centralize, you can centralize as many as you want, or in what is operational beneficial for you. Now, we stress tested Netdata parent versus Prometheus on 500 servers, 40,000 containers. And these are the results. Netdata needs 1/3 less CPU, half the memory, 10% less bandwidth, almost no disk I/O compared to Prometheus. And of course, we have a much better retention, disk footprint. So we beat Prometheus in every aspect. This is an independent report from the University of Amsterdam, where they did an analysis on the impact of monitoring systems on Docker, of monitoring observability solutions on Docker-based systems, and they found that Netdata is the most efficient agent and excels in terms of performance and has no impact at all in the monitored applications. We support CNCF, but we don't incubate in CNCF. The problem is that CNCF wants to take ownership of the product, so they want to control the roadmap. We didn't want that. So, but still, we are one of the most popular, or not one, we're the most popular projects in the CNCF landscape for observability, of course. Now, the first is, we talked about this, how we come up with a fully automated system, a system that you just install and it's a full monitoring solution without you doing anything. So what we did there is that we developed the needle framework. This is a framework that says that, for the guys that know Prometheus, in Prometheus you have a metric and then you have some labels. What we say is, wait a moment, not all the labels are the same. Some labels have special meaning. And we need some more metadata there. Like what's an instance? These are 5 metrics of a disk or of an Nginx, of a specific Nginx. So we need more metadata there. So once we added this metadata, we came up with this. So there is a context that is the metric in Prometheus. There are instances, there are dimensions, reads and writes, and then there are labels, of course. The idea is that by using this, we get fully automated visualization, so our visualizer is not a custom dashboard. Oh, we sit down and say, okay, Nginx, let's do it like this. Postgres, let's do it like that. No. The visualizer takes the metadata and has an algorithm there to render the dashboard for everything. Okay? So it's a fully automated dashboard. Fully automated alerts. For alerts, we did something smarter. We said that, okay, alerts should be, if we have alerts monitoring all the components, component by component, then actually we have a watchdog across the infrastructure. We monitor everything. So our alerts attach themselves to every instance. An instance can be a disk, one disk, a network interface, an Nginx instance, an instance of Postgres. But if you can go deeper, an instance of a table in a Postgres server. So at any level, we define an instance, and then we can attach automatically alerts to them. So we ship Netdata with 350 alerts that say, okay, On Postgres do this, on Nginx do this, on network interfaces this, on whatever it is. So we ship 350 alerts. So that's the first mission accomplished. The second was how to get rid of the query language. So how we can, in a data dashboard, you are going to install it, and it will come up, and thousands of metrics without you knowing anything. Okay? You are going to see the dashboard for the first time. How we can help you users grasp this? How we can help users see the dashboard and say, okay, I understand. Huh? So we developed a framework there based on the Needle framework. Of course, we added an info for you to see what every chart is. But then we did this. The first is that everywhere there is an anomaly ribbon. This anomaly ribbon shows anomalies across time for the entire chart, whatever the chart has, all the data. Then it has these controls that allow you to slice and dice the chart, any chart. Now, these controls, when you click it, I clicked nodes. I get something like this. So I get a list of the nodes that contribute to the chart. And you see here that it says the contribution of every node to the chart. This is the volume contribution. So 16% comes from the first of the chart. If I remove that node, 16% less the volume of the chart. The anomaly rate per node, and you have the minimum, minimum average and maximum values of the raw database. If you want to regroup, so this is the group, and you can change the grouping, that is the visible dimensions, as you wish. So here I selected, I want the dimension, so read-write, and the device type, so physical and virtual, and I got this. Reads physical, writes virtual, writes physical, writes virtual. So I can regroup any chart just on the UI. The idea with this is to allow people understand the data while they work. They see the data for the first time. Just click on the menus, and you're done. This bar, the lower bar, is the info bar. So when data are missing, you get this, empty data, and this is highlighted, of course. This bar is highlighted. So missing data are visualized. So that's another mission accomplished on how to come up with fully automated visualization. Machine learning. In 2019, Google said that all their ML ideas are bad. So they asked Google engineers, what do you expect from ML? They said ideas, they tried them, they failed, all of them. Okay, and they did this presentation. This does not mean that ML is bad. This means that their ideas, the ideas of DevOps and SREs were bad. So what do we know? What do we do in a data? We train up to 18 machine learning models per time series. Per time series. So once you have all these machine learning models, actually you have modeled the past of a metric. We learned about 2.5 days of the past of a metric. Once you learn the behavior, the patterns of the metrics on the servers, we don't train the model somewhere else to apply them there. These are trained at the edge. On the server, the metrics are collected. So when you have this, then you can detect anomalies in real time. And the 18 models are used first to have a rolling. So we remove one model, we add one. So this is how we accomplish a rolling nature on machine learning. And the second is that accuracy is significantly improved. So a lot of noise is reduced in the process because machine learning is noisy. We developed a scoring engine. A scoring engine allows all Netdata to score all the metrics according to an algorithm, anomaly rate, for example, for a given window, so that when you sort them, you have an ordered list, a sorted list of what is important. So we use this for for several purposes. One is this. So this is a dashboard of Netdata. This is the menu. But when you press the button, the AR button there, that button, Netdata annotates all the sections with anomaly rate for the visible time frame. So you can go to the past. You can do this for yesterday or for a week ago. This allows you to say, hey, what is anomalous now? What's anomalous today? Just enter today, hit the button, boom. The second is that we understood that anomalies happen in clusters. I can skip this to go a little bit faster. So for this chart, every line is a node. Every line is a node. And the y-axis is the percentage of metrics of that node that are anomalous concurrently. Now look at the interesting part. You see that a lot of metrics, this is 6% of all the metrics on a node got anomalous together at the same time. But the beauty of this is that it happens across nodes too. So this node got anomalous, and after some time, the others were influenced. Here, they were influenced together. One node got anomalous, the other got anomalous concurrently. So we realized that anomalies happen in clusters, and this allows you actually to highlight an area here and get a breakdown, an ordered list of all the metrics, all the time series from all nodes. So your aha moment, do you remember the speculation that I was saying at the beginning, how you troubleshoot? With Netdata, you highlight the thing, a list of metrics is presented, and your aha moment, the disk did that? Resets, network resets? Are you serious? Nginx did that? Postgres did that? It's there. You don't need to speculate. I don't have time. I do. I am. So, mission accomplished, another mission accomplished, unsupervised anomaly detection for every metric. So, Netdata is AI-powered and 100% to help people. Logs. For logs, how many of you know the systemd journal D? Do you know systemd journal D? So we were designing our own log management solution, like LK and Loki and the likes. We were writing our own. But then I realized what systemd journal D is. So systemd journal D, let's go the other way around. Elastic indexes words. So you give it a string, whatever it is, it indexes every word, okay? Heavy. So if you have 1 GB of uncompressed logs, Elastic needs 3 GB plus for indexes. Then you have Loki. Loki is like the log files. So actually there are no fields there, nothing dynamic, they are streams. And the logs on the stream are one after another, nothing is indexed, okay? This is the most efficient in terms of footprint. So for 1 GB of uncompressed data, it needs 250 mega. But nothing is indexed. Almost nothing is indexed. So you have to rely on the visualization, etc. Then you have systemd journal D. That thing is exactly in the middle. So it can accept any number of fields and any number of values on any field on every log line. And it indexes all fields and their values, the whole value as it is. It doesn't split the value. Now, this means it needs, on a disk footprint, it needs twice. So on uncompressed, it's a 1 GB, it needs 2 GB, okay? If you put the journal files in a compressed file system, BTRFS, ZFS, and the likes, then it needs 500 mega, so it's half of the original. But the beauty of this is that it gives amazing flexibility. So what we did is that we created a UI for that thing. We open the journal files as they are. And we do run queries on them. And we give you a Kibana or Grafana Loki-like user interface for you to explore the logs at the point they are on the servers. Don't move them. You don't need a logs database server. Some people say systemd journal D is slow to query. Yes, it was. We submitted patches to systemd to make it 14 times faster. These are merged already in version 256. It lacks integration, so how can I get a log file, extract fields to it, from it, and put it in systemd journal. There is no tooling. We created log2journal that does exactly this, like promtail, but this time it tails a log file, extract fields from the log file using patterns, puts structured data into systemd journal. And another mission accomplished, and I think that's the last one. Yes, so the last one is about a thing that I believe is more than metrics, logs, and traces. So we all say that observability is metrics, logs, and traces, but not exactly. So what we do is the following. Each one of our plugins, so all servers here are, of course, run data plugins, data collection plugins, but our plugins have the ability to expose functions. So the plugin that connects to Postgres to collect data from Postgres can say, hey, I define a function that I call it Postgres slow queries. So every time you run it, I'm going to give you back the list of currently running Postgres slow queries. The same way, you can have anything. Give me directory listing, give me the sockets of the system, give me whatever imaginable, it doesn't matter. So what we did, this is a sockets explorer. TCP and UDP sockets, and you can filter and see them on a chart, etc. This is live, of course. Everything is moving there as the refreshes are done. So that's another mission accomplished, and I am closing. Netdata Cloud is a SaaS offering. It has a free tier. This is what it adds on top of the open source. So it adds horizontal scalability. Without the SaaS, you have a big parent, as much as the big parent can be. Otherwise, you can have a second, but they are not related. You cannot combine them. With Netdata Cloud, you get this combined view. Role-based access, access from anywhere, of course. You have a mobile app for notifications, and you have a lot more customizations and dynamic configuration and custom dashboards and the likes. That's it. Thank you very much.
Thank you.